I get to talk to you about something that I care about so much. And I'm so lucky because I have been able to spend the last 15 years of my life doing the thing I love. And so that's what I'm going to talk to you about today. And I want to hear from you. I want to hear your questions. I want to hear your ideas.
Kids Tech University is a program for children ages 9 to 12 to come and enjoy a campus life at Virginia Tech. And it's co-ran, sponsored, and organized by Fralin Life Sciences Institute at Virginia Tech and also 4-H. Each day of Kids Tech University, we really try hard to focus on one particular theme, specifically looking at STEM. So we've got science, technology, engineering, and mathematics.
Sure that you know I'm throwing it to you, I know I'm throwing it to you.
Okay.
Can everybody hear me okay? Excellent. Good morning. My name is Jennifer Russell. I'm a professor here at Virginia Tech. I go by she, her pronouns, and I also don't really need you to call me professor or doctor. You can call me Jennifer, Jen, or anything really, as long as it's not going to hurt my feelings. I'm really, really excited to be here with you today because I'm very, very excited about this orange box because I have a lot of questions for you. And so we're hopefully going to be throwing it around a lot. I've never used this before, so let me know if I'm asking too many questions. That might be my concern now, is that I'll ask you so many questions that the box will be flying around and maybe we'll have some issues. Anyway, we're going to get started today, and the big theme of what I'm going to talk to you about is this idea of sustainability and how systems thinking and system science can help us to deal with problems and challenges that come up related to sustainability. Just a really quick show of hands. Who here has heard the word sustainability before? Wonderful. Okay. Sustainability is a word that's really common nowadays. We use it when we're talking about businesses. We use it when we're talking about environment. We use it when we're talking about the future. But I'm going to talk to you about how do scientists think about sustainability and how do we start to organize that information so that we can actually help to fix some problems. But before I do that, I want to share two stories with you that are really about why I am now doing what I do. And so the first story is about a forest that I really, really cared about. And I drew this picture myself, so if it doesn't look like a forest, I apologize. I'm not an artist, but it's a forest. And this forest was near the school that I went to when I was younger. I went to this school from the age of 5 to 13. And behind this school was this beautiful forest. And after school every day, me and my friends would go and we would play in the forest. And there were lots of trees and lots of animals, and we would build forts and we would run around. And it was so important to my life. Even when it wasn't school time, on the weekends, we would take our bikes there. We would throw rocks in the river, all of these things that were really important. I loved to be in this forest. And then one day we came to school and someone had put up big fences all around the area that we used to be able to go in. And the fences said, do not enter, construction. And what I found out was that the town that owned that forest land had decided to sell it to a company that wanted to build houses. And I was very surprised. I didn't know that was going to happen. And I was also very, very upset because I had named the chipmunks that lived in the tree near where I had a fort. And I knew every path and trail. And it was so deeply personal to me. And someone else decided, without talking to me, that not only was I not allowed to use that anymore, but they were going to cut down a lot of those trees. And they were going to bulldoze the land to make it flat. And they were going to build something there. So that really bothered me for two reasons. One, I cared about it and I didn't want it to be destroyed. The other was how powerless I felt. I could not figure out how to fix this. I was 10 years old and I did not know who to talk to. I didn't know what questions to ask. And I really hated it. That made me really angry and motivated to figure out what the heck is going on here. So then I'll fast track to my second story. And this is a lake. It might not look like a lake, but it is. This is a lake that I cared about. So when the forest was not somewhere that existed anymore, a little bit further away from my house was this lake. We could ride our bikes to it, we could swim in it, we could fish in it. And this is several years later now. So I'm in high school, I'm about 15 years old. And the lake started to change color. And that's one thing you see here. Again, I'm not the best of artists, but once upon a time it was blue and it had fish in it and it had frogs and birds. And then it started to turn green. And these bulrushes appeared around the edges and they started to grow into the lake. And soon there was no lake anymore because it was being filled up with algae and swamp type plants and bulrushes. And I didn't understand why that was happening, but I also was, really upset. This thing that I loved, that was so important to me, was being affected, and I didn't understand why. Didn't understand why it was being taken away. So these two big events when I was a child really motivated everything that I've done since. I don't like not understanding why a problem exists. Anybody ever feel the same? Like something's going on, you don't know why, and not knowing is almost as frustrating as seeing that there's a problem. So that really put me on my path to what I do now. I went to school, I did all my homework, I got the grades, I did other things too. I went to university, but way back then, a really long time ago, the word sustainability didn't exist. It was environment. You could study the lakes or the trees. And then there was business, and you could learn about the companies that I was really angry about because they were bulldozing my forest and they were doing other things that I didn't like. So I studied both. I studied environment so I could understand how these systems worked. Why did the pond turn green and get taken over by bulrushes and algae? And I also studied business because I wanted to understand how that big system worked so that I could start to act in it and not feel powerless. Yeah, we have a question. Can we throw the box out there? We'll just do one quick question because I'm taking far too long on my story.
You
What's a bulrush?
Ah, excellent. Thank you. All right. Maybe, have you heard of a cattail before? Cattail, all right. So I will also say, the thing I should have said at the start, I grew up in Canada, and sometimes Canadians use slightly different words than people who grew up in the United States. So a bulrush is the same as a cattail. You see these long poles, they usually grow near water, and they have a brown seed pod on the end. That helpful? Awesome, okay. Excellent question, and if I say things like that you're like, what is she saying? I don't know that word. Let me know, I will clarify. All right, so the point here that I really want to say is when I was your age, things were happening around me that made me upset and frustrated, and I didn't like them. And then I also figured out how to solve them. And I think that's one of the most important things when I talk to you about systems thinking today, it's to remind you that you actually have so much power. You have so many decisions and ideas, and they really matter. And if you follow through on those, you can help to fix some of the problems that are out there. So today in general, I'm a professor. I'm going to have lists sometimes. There are 5 big ideas that we're going to cover. The first one is humans are a part of nature. Sometimes we talk about humans and cities and the things that humans do as if they're not connected to nature. But at the end of the day, we are animals. We are also really connected to those natural systems. We need clean water. We need food. We need space to live. We need building materials. We need the clothes on our bodies. And all of those things come from nature in some way. We're also impacted by nature. Has anybody been affected by the really bad ice storms and bad weather that we've been having? Right? So nature can also impact us. Sometimes nature impacts us in a good way when we have a beautiful sunny day like today. Sometimes it's going to be not so good. We are a part of nature. We are not separate from it, even if that's how people talk sometimes. The second thing that I want you to think about, you take nothing else away, is this idea that sustainability, so many of you raise your hands, you've heard of sustainability before, but usually, right, that's about the environment, right? When we talk about sustainability, we're talking about air or water or animals. Sustainability is actually about balancing three different types of systems: social systems, the humans and the relationships and everything that we do, the economic systems, jobs and companies, and the environmental systems that create all of those resources that we need. So there's three things that need to be maintained when we talk about sustainability. It's not just environment. We can learn a lot from nature. A lot of the science that happens at Virginia Tech is actually looking to nature to see how can we mimic that. When we look to nature for solutions, that's actually how we're going to solve most of our problems. The things that we do, all of our activities, they also have impacts. They can be harmful impacts, right? People who bulldoze the forest that I loved. They can also be really good impacts. People who then replant trees, or who pick up litter, or who act to help and preserve it. So humans are part of nature, and we can do things that harm it. We can also do things that help it. And that's really where we have so much power, is in what we choose to do. And the science behind all of that, the way we know if we're going to do something that's causing harm or benefit, is by measuring those impacts. And that's a lot of the work that I do now. I'm going to talk to you about a tool that we use to help understand good and harmful impacts. Once we know those impacts, it helps us to make better decisions in the future, so we don't have to keep making the same mistakes over and over. So we'll start out by talking about what is sustainability science, this big picture idea. We'll talk about how do we measure impacts of the things that we use, and some different tools or strategies to make it better. So about 40 years ago, almost 40 years ago, big major leaders from all around the world gathered in Rio de Janeiro in Brazil to have a conversation about what sustainability might mean. Because 40 years ago, it wasn't a word that people really understood or used. They developed a report. It's called the Brundtland Report. It's also called Our Common Future. In 1987, people were realizing that water pollution and air pollution was actually becoming a problem for humans. It was making us less healthy. It was hurting our economies. It was causing damage to not just the environment, but also all the things that we wanted to do. So all of these governments came together and they decided on an idea. What if we set out a vision for the future that we can all work towards? So the definition that this group came up with for what is sustainability is looking at now and the future. Both are critical, meeting the needs of current generations, everybody who's around right now, all over the planet, without compromising the ability of future generations to meet their needs as well. So this is saying my family matters, my community matters, and my grandchildren, their families matter, their communities matter. And I don't want to do things today that's going to make it harder for them in the future. So we're going to get that orange box out now. I've got these two words up here, needs, right? Meeting our needs now and in the future. What do you think it is that we mean by needs? I'm going to let Mr. Ty pick this one. Thank you.
Pass it to you.
Needs means we need clothes, shelter, food, water. We need those things to be alive.
Excellent. Clothes, shelter, food, water. Awesome list. All right. Do you want to toss it to someone else? Remember that eye contact, maybe pointing.
Needs means like stuff that you need to survive, like food, water, stuff like that. And also air. If you don't have air, you die.
Exactly, right? All these things that if we don't have them, we don't keep continuing.
It's only the things that are necessary. Like we have wants, like we want to have this, we want to have that, but things we need are things that will help us move forward and will help us survive.
I really like the distinction you made. There's wants and there's needs, and they're not necessarily the same.
In the red shirt. Things we can't survive without.
Right? Excellent. Things we can't survive without.
Needs are something that you can't live without. And if you don't have what you need, then you'll die.
Right. And think about that as we pass the cube around. Think about it will come back. Think about what that means, not just for us, right? But all the people on the planet.
Needs are things that like we need to survive, like food, water, shelter, clothing, and healthy air to
Absolutely.
breathe.
I love this. You are all, you know this just as well as I do. Nice work. All right, maybe 2 more ideas and then we'll push forward.
I think that needs are something that you need to survive, like food and water.
Excellent. Do 1 more. These are all great suggestions.
Needs are like things that if they're taken away from you, you die.
Yes. Or we get very, very uncomfortable, right? If it's a cold day and our warm coat is taken away from us, we might not die right away, but that's not a nice way to live. Did anybody lose power in the last few weeks with all the ice? I did, right? So all of the examples that you provided are great. What systems thinking tells us is that we start with food and water and clean air. We have to dig deeper, right? How do we buy food? Money. We can grow food, right? We could grow it. Right. So the suggestion is we could grow it or we could buy it. If you want to grow it, you need a garden, right? You need seeds somehow, right? Maybe you have to buy the seeds, or maybe you have them because you ate an apple and you saved the apple seeds. Maybe that's how. Very excellent question. You are going to, maybe you found it on the floor. Maybe you picked it off of a tree. Exactly. So this is system thinking. You guys know how to do this. We start with the one idea and we dig a little bit deeper. We need water. Check. We need clean water because we don't want to drink the green, yellow water that I showed you in my picture. You don't want to drink water that has harmful things in it, pollutants, plastics, right? So we need water. We need clean water. Well, how do we have clean water? How do we keep it clean? Systems thinking is really about asking questions. Exactly. Maybe we don't pollute it. What I've got up here is a list of things that sustainability scientists think about when we think about needs. And you've all hit on some really, really great ideas. Okay, so in this society or humans space, we need health, right? We need to be healthy. There's lots of ways that we can be healthy. We can eat healthy food, we can have exercise, we can take vitamins or medication if we need to, we can have a doctor if we get sick, we can have a hospital if we hurt ourselves. Health is something that we need. If we don't have our health, we don't really keep living, or we don't really have all the comfort that we might want. Education. When everybody gets to go to school and learns how to do math together and learns how to read and communicate and learns about the natural environment. If we want to have grocery stores and schools, we need roads and buildings, right? Dig deeper. Education is great, but where does it happen? Even if you don't go to a school, you might need a laptop and a Wi-Fi connection to be able to do that. If we want to buy food or buy clothing because we can't grow it ourselves, we need stores. We need businesses to make those things and sell them. Anybody here also like, I told you 2 stories about how I love to be outside. Anybody else here love to be outside? Awesome. Outside on a playground, outside in the woods, maybe just outside playing baseball or basketball or football or whatever sports you like to do. Being outside is great. That means we also need space. We need the balls. We need the rules. We need referees.
So any of our students that are online, I know we have some students from Churchland Primary, Elementary, and then from the Portsmouth area or Hampton Roads. You can go on Zoom in the question and answer, and then you can put your questions there, and Dr. Russell can get them in real time. And so she is going to be taking pauses where then she can look at the questions and answer, and then she can give some answers for the people that are online, right? I can do that. It'll be great. So whenever you're ready, just look at me, and I'm going to be in the back of the hall. Everything will be great.
Thank you. Yes. Wonderful. And also welcome to everybody who is not in the room. All the questions are great. All right. So if we're humans, human societies and towns and cities and everything that you do needs some of these needs, right? Not just what we consume, clean air, clean water, and food, but where does that come from? Who makes it? How do we get it? And that's where this economy pillar comes in, right? When we need money to buy things, the way we get money is through jobs, right? So we need jobs, we need businesses to employ people, we need manufacturing activities to make those things. Services are really important. There's a lot of things we need that are not about a physical phone or water bottle. The people who plow the roads, the people who keep us safe in our communities. Trade. Has anybody ever eaten a pineapple? A banana? Do we grow those in the United States? Right. So trade means we have to have relationships with other countries that can grow those things. And other countries can do lots of amazing things that we maybe can't. So we need to figure out how to trade. We need to have banking systems to save products to fill those needs that we have. Long, long list. The third category is the environment. And this is the one that, because it's often pictured so far away, we have human communities, towns or cities, and then the environment is everything else. But it's in that everything else space that we get all the things we need. Clean air, clean water, healthy soil, right? We can't grow food if we don't have healthy soil. Animals and fish, they do really important things in their ecosystem, even if we don't eat them, right? And people choose not to eat them, which is cool, but they do really important things regardless of humans. The weather. We don't like bad weather, but we love good weather. And good weather can be many things for many different people. Sometimes I like going to the beach and being really hot, and sometimes I'm like done with hot weather. I want it to be snowy. I want to go tobogganing or some tobogganing is like sledding. Sorry, Canadian word maybe. We need plants and trees to do a lot of the work. We need fungi and decomposers to break things down. We need land. We need water and oceans. We could make this whole page filled up with lists of things that we need and all of the other parts of those systems that are then necessary as a result. It looks like there's some strong questions. So I will pause right now if there's any questions from the online community or in the room as well.
You have had your hand up for a minute.
But what if we grow our own pineapple and other stuff?
It's a really great question. And some people can do that, right? If you live in a part of the country that has really warm climate and all the things you need to grow a pineapple, definitely you should do that. I mean, I know there's a lot of oranges that come out of Florida, right? But Virginia doesn't grow oranges that well. It's a different climate. Good question.
So, with the lake that got covered in algae, do you know if it's like because of fertilizer runoff?
Yes, that's exactly what was happening.
Oh, okay.
Yes. So that I'll come back to that.
What happens if like only one of these goes away, like say jobs goes away, what would happen?
That is an excellent question. And if you give me 2 minutes, we're going to talk about exactly what happens if one of those goes away. Before I do that, I'm going to invite if there's questions online.
Yes. Yes.
It could involve the government. That's a very good point. So whether we have government or not, so imagine this, human society 500 years ago, maybe even longer, say 1,000 years ago, right? We still had all these needs. Government is not necessarily something we need directly, but sometimes governments can help us organize and create money to build the things we need. So for example, in Blacksburg, in Montgomery County, in the New River Valley, we rely on governments to help make sure that we have buildings and roads, and that we have snowplows, and that we have schools. So governments are not directly in need, but they do a really important job of helping to make sure that we get some of these things that are otherwise harder to do. I think, what is the question?
In the environment, when you said animals and fish and plants and trees, why didn't you just say animals or plants?
Well, in my mind, they're a little bit different.
Why?
So if we talk about how animals help a forest to function, it's going to be very different than how fish help the ocean or lake to function. The work that they do in that system is a little bit different. So I tried not to lump them together, because if we are going to talk about land and water as being two separate things, then all the species that are part of land ecosystems or water ecosystems, we can also distinguish them.
But not everything in the ocean are fish.
This is a very good point. I didn't want to have too many words on this. Right. Excellent point. All the things in the ocean. Very good point.
And what about the plants and trees?
The plants and the trees? Well, to my mind, I was thinking about how plants connect to food, right?
So do trees. They grow apples, pineapples.
They do, right? But it's a different kind. We don't eat the tree directly. We eat the thing that comes off the tree. That was how I was thinking about it. But very good questions. And I will be much more careful with my slides in the future. I'm going to push forward. Got great questions, and we're going to keep having more. But back to that question of what happens if some of these things are not working. That is the true challenge of sustainability and sustainability science. Two main ways that people who do sustainability work think about it. First one is this idea of a three-legged stool. Does everybody know what a stool is? Excellent. Okay. In this three-legged stool, we have our society pieces, right? It's buildings, schools, education, health. In the middle, we have economy. What are some of the things we had listed in the economy? Jobs, businesses, money, trade. Excellent. You all got this. So all those things in the economy bar. And then we have the environment. Plants, trees, fish, food, fruit, vegetables, mammals of all types, invertebrates, water, air, everything. What happens to a stool if one of these legs is shorter than the others? Falls over. What happens to one of these legs if it gets, or sorry, to the stool if one of the legs gets broken? Falls, right. So one way we can think about sustainability is that all of these things need to be kept in balance. And not just balance so that we could sit on it, but balance so that we could have a really full cup of water on top of it and not spill it. That takes a lot of work, right? That means we have to measure how much is in each of those legs of the stool. And when we notice that one of those is maybe off balance, we don't want that water to spill. We've got to do something. Another way that we could think about sustainability is much more complex. And some of the things that you all have been raising, fertilizer use, atmospheric change, climate change, these are important pieces of it. So this is an image from what's been called the donut economy. The reason it's called the donut economy, can you guess? It looks like a donut, so it's called the donut economy. The main thing about the donut economy is it organizes all of these needs that we need to think about, right? All of the things in the middle: education, health, food, water, housing, peace and justice, political voice to the government question. All of these things that are important for human communities are in the middle, and we call this the social foundation. We need these things to be happy and healthy and thrive and not die. Using your words. On the outside, we have, it's called planetary boundaries. Has everybody heard that we don't have, infinite supply of materials and resources? Right. So some things we can run out of, some things if we use too fast or don't replace it, or some systems if we cause too much harm will not function anymore. Those are based around the outside. Fresh water, right? How much clean drinking water do we take out of the ground to consume? A lot, right? And do we put it back? Oh my gosh, yeah, you guys know this. I don't even need to go through this. But you're right. We're using things at very fast rates. We're using water that's drinkable, right? We can't drink salt water from the ocean. So the water that is potable, fresh water, it takes time for it to be cleaned. Land conversion. How quickly are we using up land that could grow food, agriculture, trees? Very fast, exactly. We have other things that are up here as well, right? Nitrogen and phosphorus loading. That's what happened in the lake. Nitrogen and phosphorus are really valuable elements. They help plants to grow really, really quickly. We put them on agriculture or farm fields to help farming plants grow quickly. But when those make their way into a river or a lake, it helps the algae to grow quickly too. And when algae starts to grow in a lake, it changes the whole ecosystem. It turns it green, and then certain fish and other things can't live there anymore. The lake becomes a swamp. Chemical pollution, you probably know all about that. Ocean acidification, the acidity level increasing so that some species can't survive anymore. The donut economy tells us that we need to aim a different kind of balance. All the things that humans need, but not exceeding these planetary boundaries. And we can call that like a sweet spot. The sweet spot between what humans need to thrive and be well and the real limits to what the earth can handle.
So, Dr. Russell, why does it look like a donut again? One of the questions that we had online is why is it represented this way?
It's an excellent question, and I can't take credit for that. This was actually an image created by someone who was an economy scientist. She's an economist. She's received the Nobel Prize for her idea. She used to focus only on how do we make money? How do we run businesses? And she realized, her name is Dr. Kate Raworth, she realized that if all we do is focus on this economy pillar, the others will suffer. And so she just drew it in this way and called it the donut economy. So that's why it's called the donut economy. Somebody else drew a picture of it, trying to figure out this balance, this idea of balance. So whether you think of it as a stool with 3 legs, or you think of it as this donut, and we're trying to find the safe spot in the middle, it's both about balance. Can we maybe, yes, I know you have a question.
I realized that it says shortfall and overshoot. So it means that we have like a lot of climate change and a lot of air pollution and less housing and gender equality and peace and justice.
Excellent. A big issue that we're facing in the world right now is that we have focused on the economy pillar, that economy leg of the stool, far more than the other two. And because of that, we have not done as good a job at providing these things in the middle that we need. And we've also started to push past, overshoot what the earth can handle. Yeah, I follow up.
It's like you're like leaning in your chair and the legs get weaker and weaker and then they'll just collapse.
That's a very good analogy.
Yeah,
Right,
except
it's
for
a
the ones you
stool.
don't lean on.
Yes. So this is excellent point. Overshoot and shortfall are talking about the consequences if we don't balance that stool properly. If all we do is focus on jobs and money, which are important, but if that's all we focus on, we risk causing a lot of other problems in the systems that we need to be balancing. So, really quickly, and I know you know the answers to this, so I'm really excited to hear what you say. That outer limit, we call it planetary boundaries. What can the Earth actually handle? We're part of nature, right? But we're not always living in balance with the systems around us. One of the ways we can think about boundaries, first thing is think about it like a pizza, right? Some of the resources we have are like pizza. Once we eat that pizza, right? You're at a birthday party, somebody orders pizza, everybody takes a slice, and then what happens? They're gone, right? So if we take a lot of time and money, maybe we can get some more, but maybe not. Maybe it's just gone. This way of thinking is where we would think about our non-renewable resources. There's only so much, and when it's gone, it's gone. Another way of thinking about these resources is like an apple tree, right? Renewable resources. The thing that people often forget, though, is that renewable doesn't mean instantaneous. The apple tree will only make apples certain times of the year. And if we eat all those apples in the first week, we don't have any more. They will grow more again next year, but not at the rate that we want and consume them. So resources that are like apples, renewable resources, we can get more of those, but it does take time and effort and patience. And humans are not always good at patience. That's one of our big challenges as a species. So really quickly, I want to say, what are some other resources that are non-renewable, like pizza? Let me throw that thing around, please.
Coal.
Coal, excellent, yeah. Coal is mined out of the ground, and there's only so much of it to go around. Yeah, pick somebody else to throw it to.
I wanted to say that there are perpetual resources.
Interesting, tell me more.
Like the sunlight.
Mm-hmm. Yes, that is a
that
good point.
instantly replenishes.
We can definitely talk about the sun. The sun has been the reason that there is life on Earth. The sun is actually the only thing that enters the Earth's atmosphere, the only resource that isn't part of our system, because it keeps coming in. But the sun also is not going to last forever. And we know this from studying other stars. Now, that's probably not going to be in our lifetime. But what we do know from the universe, we watch the universe, we know from science, we've been here for a long time as humans, we do know that some things will just run out. Or some things will regenerate themselves if we give it enough time. So even the example of coal being non-renewable, we can actually make lots more coal. We just need hundreds of thousands of years to do it. We are not going to be around that long, maybe, or we're not willing to wait that long.
So somebody online mentioned diamonds as a non-renewable resource.
Mm-hmm.
And then also a question is fossil fuels a non-renewable resource?
Excellent. So fossil fuels, we talk a lot about fossil fuels now, right? We've heard a lot about them. What are fossil fuels from? Basically decomposing old organic matter, right? Millions of years ago, there were trees and plants and organisms. Dinosaurs were a part of that, but also hundreds of thousands of other species. And when they passed away, that organic matter became compressed and modified within the earth. And that is fossil fuels. It's fossil because it's derived from fossils, right? Old plant and animal material. So they are non-renewable in our lifetime. If we have 100 million years to wait, we will still have fossil fuels in the planet. But we will not be able to regenerate fossil fuels in the next 100 years or 200 years. And so it's that mismatch of how much do we want to take out versus how fast it can be created in the first place. Who has the cube? Want to throw this back into the, do you have a question back there?
Well, he had the
Or a comment?
yeah. This kind of goes back to the three-legged stool.
Mm-hmm.
But what if one of the legs gets like too long? Or
yeah. Well, what's going to happen if one of the legs gets too long?
the water's gonna spill?
Right, exactly. It doesn't, that balance, it doesn't mean that we have to break a leg. We could just make one leg longer than the others. It's still not going to balance. And that's the challenge. Do you want to throw the cube to someone else? Or?
About the non-renewable resources, I was gonna say a donut because if you eat it, it's gone.
This is, well, right. So, but then, so if you want to buy, this is a very good point, right?
But you're still gonna eat it.
Exactly. So renewable depends on, do we have time? Do we have money? And do we have the other things you need to make a donut, like flour and sugar and icing and sprinkles? So some things we can renew, but to do that, it needs other inputs. And that's the real difference between the two, is can we do this with what we have available in the time that we have to use or not? I know you all have lots of ideas here. I want you to also think about this other question. What are the renewable, or what are the resources that are more like apples that are renewable?
Let's pass it to someone.
Yeah, who has the cube? Yes, throw it to whoever, as long as you got the rules of throwing in place.
So, what about matter and energy? Because they can neither be created nor destroyed.
Absolutely. So this is a really great question, right? There are many things in the universe that will continue if humans are not around. The reason that we care about this donut, oops, let me go back to the donut picture. It's not working. There we go. There. Thank you. The reason we care about this or the three-legged stool is because we care about ourselves, right? If humans are not here, the sun will keep shining, the animals will keep doing their thing, the trees will keep growing. They did that before humans were here, and it will continue. If we want to be a part of that, that's why we need to think about these ways of understanding systems.
Okay.
So I would love to hear if anyone has any suggestions about these renewable resources.
Okay.
Powerful toss.
Aren't like things like pizza and stuff actually renewable? Cause like because like bread is easy, can be made with wheat, tomato can be made into tomato sauce, and the cheese with the milk and stuff.
Yeah. So excellent. This is the really important thing, what we want to think about. We can make more pizza if we have flour, if we have cheese, if we have sauce, if we have the money to get those things, if we have the farms producing those things, if we have healthy cows and productive soil to grow the wheat. So they are renewable if we have all of those other systems that are needed. And one of the challenges is that sometimes we just treat it like it's easy to get it. And that's also why we have a problem of consuming so much, because we forget about everything that actually goes into it. And that's one of the tools I'm going to talk about in a few minutes. How do we start to appreciate how these systems are connected? Because renewable and non-renewable, that doesn't really make sense. And you are all asking the right questions. That way of thinking about resources is not necessarily going to help us. What we need to think about is, do we have what we need when we need it? And can we make sure that future generations, your children's children's children, we make sure that they also have those things? I love all the questions. I'm gonna keep going though because I'm gonna ask you another question and you can tag on, right? Ask and answer. We have these two different ways of thinking about sustainability, and there are actually lots, right? Sustainability scientists keep proposing new ways to think about it, but these are the ones that I find really helpful. We have a stool that we need to balance a really full cup of water on, which means we need to think about each of these buckets and how we are managing it. We also have this idea of a sweet spot, the donut economy. How do we provide all humans with the things they need to be healthy and happy and thriving? And can we do it without overshooting on these planetary boundaries? So how do you think we could know if we're in balance or if we're in that sweet spot? And you've got do you have a question? Yes, please go ahead.
So something that I was going to say about the donut, an analogy that I made, is that the overshoot and the shortfall, they're kind of like the bread of the donut, and then the sweet spot in the middle, that's in between the social foundation line and the ecological ceiling line. That's like the jelly filling of the donut.
Excellent. Or like that stripe on the top where all the sprinkles actually stick to the icing. That's a really good insight. That's a better answer to the question about why a donut. Really good. Thank you.
I wanted to mention something about before a couple of slides. I think it was the first slide.
Yeah.
It said forgot the word, not stop the next generation from having these resources.
Yep.
We need to make sure that we don't use all of it and don't destroy one to make another one.
Exactly.
That might be less useful because we need other people to be able to have those supplies to live and thrive.
Exactly. So that idea, if we look back at these apples, right? If we eat all the pizza,
it's gone.
It's gone. We could make another one, but it's going to take time and other resources and other things. So if we eat it all, there is none left for future generations. Apples, we could probably keep growing apples. Future generations could probably have apples, but not if we do damage to the soil, not if we cut down the apple tree orchard to build new
Houses
things.
and buildings.
Right. So part of it is about not consuming everything all at once. And the other part is about making sure we protect the systems we need to keep growing them in the future.
Mm-hmm.
Good point. Yes, please take someone else. We're going to come back to this, but obviously I love all your questions, so keep them coming. But anybody have any idea, how can we know if our systems are in balance or in that sweet spot?
I see somebody in the back with the blue t-shirt on you, but I can't vote that far. Can I pass it to somebody
maybe
else?
Mr. Ty can help.
Yeah.
Okay.
So, we would know if it's the sweet spot by if it's good, but it has a balance of the three things: the economy and the society and the environment.
Excellent. Yeah. So what you're talking about is we'll know we're in this spot if we also have an idea of, does everybody have the things they need in the middle? And are we taking good care of these planetary boundaries? So that's the way we won't know if we're in the sweet spot unless we look out and around us.
If we have enough plants and enough jobs for people.
Wonderful. Wonderful.
We'll know if they're all balanced, if there's no poverty in the world, if there's no pollutants in the water or the air, if everything in the world is just right.
That's a very good point, right? So one of the ways we could know that everything's going great is if we stop seeing all the problems.
Mm-hmm.
Right? It's a very tough challenge. So this is also why we have a lot of science and research happening, because we have to know what's going on. We need to look out and around and understand that to know if it's actually starting to work.
It kind of goes back to the pizza and apples is like pizza's kind of like a want and apples are like a need.
That's a really thoughtful response. I really appreciate it because when you think about it, that actually also ties to our health as well, right? There's things that we can and need to consume because they keep our bodies going. And apple trees do more than just give us apples. They also clean the air and help the soil and support all kinds of other species. Pizza is not always so healthy if it's the only thing we eat. And it doesn't really create any other systems or support any other species. All right, let's do 2 more comments. So pick your person and toss it out.
We know when we're in the sweet spot when the nature and the forest are healthy and there's no pollutants or bad stuff in the water and air.
Wonderful.
So with the apples and the pizza, if we ate all the apples, we would get more over time. But if we got rid of the tree, the apples would stop are codependent on the tree, so we would have no more apples.
That is excellent systems thinking. Well done. All right, that was the two comments, because what you are all saying is true. In order to know if we have balance or if we're in that sweet spot, we need to know what's happening in these systems. Are we doing all the things that people need? Are we staying within planetary boundaries? Or another way of thinking about it, are these stool legs in balance? And we do that by measuring. So the work that sustainability scientists do, the work that I do a lot of, is measuring and modeling what happens if all the jobs go away. What happens if we cut the tree down instead of just eating all the apples? I do this on lots of different topics, but the key point here is that in order to know how we're doing, if we are doing a good job now, and if we're going to be able to keep doing it for all the future humans, we need to figure out how all of the activities that human beings do and all of the products that we make and have, how do they affect our society? How do they affect our economy? And how do they affect our environment in all different ways? And we do that first so that we can learn what are we doing that causes harm in the first place? Are we dumping a lot of fertilizer into the river and causing algal blooms to happen and swamps and lakes to change? We also do it so that we can share that information with others, right? So you hear a lot of people talking about fossil fuels, and that's because we have got lots of research and data to know the impact of using fossil fuels, not just on the environment, but on society, on health, on well-being, on jobs, on banking, on trade. We know what those impacts are. So we share what we know with the hope that that information helps people make better decisions and prevent future harm. And we also do this so that we can figure out what's going on in this big system that's so complex and figure out what we could do instead, right? How do we figure out the balance between the company that wants to cut down the forest to build houses, and people need houses, right? The houses that they built, some of my best friends ended up moving into those houses. I never would have met them if the houses hadn't been built. Houses are not bad, but there is a cost. Understanding those trade-offs and those costs helps us to make better decisions and figure out what could we do instead. All right, I'm going to take a few questions and then we're going to shift gears, right, to think about, okay, how do we measure it? How do we understand these systems?
Start off with you.
If you go back to the stool one, then what if you replace economy with something else? Like I can't really say what, but what if you replaced it with something else?
Okay, so maybe, yeah, right now economy is a lot about money. What if we got rid of all the money and instead we just traded things, right? So I'll bake you a donut if you give me an apple. That's one way of doing it. It's still going to fall into this category though, because economy is about how do we get the things we need.
But if you get rid of economy, you can still balance it.
A two-legged stool?
It'd be harder to balance, but you can still balance it.
I really like the way you're thinking. That's right. So we could theoretically balance a two-legged stool, but it will be a lot of hard work. And what I will say is this is a very feasible idea. There are a lot of people around the world who are actually thinking about, what if we change the way our economy works? All of these ideas are right. It's possible to change this system, definitely. And maybe the whole economy, maybe jobs aren't bad. Maybe businesses aren't bad, right? We don't have to call them good or bad. They are. But we could also change. What if businesses had a responsibility to make things and protect the environment, right? What if that was their job? They had to do two things, not just make stuff, but they also had to clean up the environment, or they had to support the community. So we can change what the expectations or requirements are. And this is moving into a space that is very different than what I had planned to talk about, but I love the questions. 2 more questions, then we're going to keep going.
How will the sun keep going if it's said to explode in 3.9 billion years?
Well, it won't. It won't keep going. If the sun goes away, we have a much bigger problem. But that's also something that we can't really control. And it's also something that if we take care of all the resources we have, those future generations can help to solve them. And this is where I would say, anybody ever heard of Star Trek? Right? We even right now have companies that are figuring out how do we travel to space. So I don't think we should abandon planet Earth. But I do think that we need to recognize that we are not going to be here forever. But we do want the time that we are here to be good. I love it. Amazing and fun, and everybody is what they need and thrives. Please go ahead.
This is a small question, but I'm just asking, can cats actually get rid of salt from salt water?
Cats?
Yeah. Like, can they drink salt water and just filter out every single piece of salt? Or most of it?
I have no idea. I have 3 cats. I don't know. It's a good question. What if it hurts them? Okay, so maybe what we need to do is learn from cats so that we can also drink salt water? Is that what we're saying? Yeah. Me too. I need to sleep all day. It sounds great. All right, so we're going to pause on the cat topic. It's a good question, and it might actually tie to sustainability, because the next thing we have to think about is nature has been around for millions and millions of years, far longer than humans. Nature operates in a very good, perfect balance if we don't disrupt it. So we know that it's possible. And that means that we really need to stop imagining that we have all the answers and that we're the smartest things that have ever existed. And we need to look at nature and learn from it. So whether that's trying to understand how cats can drink salt water without it hurting them, maybe that's a really cool solution. And it's not my expertise, but you could study that and solve it. And maybe that would help us with the water problems. But there's lots of other things that we learn from nature. We've got airplanes that fly around the world, and we built them and designed them by watching birds. Yeah. We learned from watching birds how to fly, I just flew in last night, right? How to get a massive, heavy metal contraption filled with humans and luggage up into the air for many, many hours at a time. And we got that from watching birds. We learn about structure and design and architecture, how to build tall buildings, how to build them safely so they don't fall over. We learn that from looking at patterns in nature. And this is the inside of a shell. It's also the origin for mathematical foundation of fractals, right? We understand the math of the universe by looking at nature. We understand how food systems work. Part of, we eat seeds, we eat rice, but these are also food sources and energy sources for all kinds of other species. Helps us understand nutrient flows. Helps us to appreciate that a tree is not going to eat rice, but a tree still needs other resources. How do we exchange materials, resources, elements to keep growing? And these energy sources, a battery, everybody's got batteries, right? You know batteries? You know what that's inspired by?
What?
Seeds, nuts, right? Very concentrated energy sources in small portable packets. We get lots of inspiration from nature. There's a lot of people studying how to make things water repellent. How do we make sure that our jackets keep us dry, our fabrics will perform? How do we go to the bottom of the ocean? We study water. We study water dynamics, how water moves through the atmosphere, how it turns from mist into rain droplets, and how it falls to the earth. And that's informing a lot of really cool design innovation that helps us figure out how to get to space. And trees help us understand breathing. We all need to breathe, right? The main thing that we breathe in is oxygen. And what do we breathe out? Carbon dioxide. Excellent. What do trees breathe in?
Carbon dioxide.
Right. What do trees breathe out?
Oxygen.
Wonderful. Isn't that a beautiful example of balance?
Mm-hmm.
It's way more complex than that, though. It's about chemical exchange, photosynthesis, respiration, evaporation. When we learn about these things, it helps us to design amazing buildings, amazing contraptions, and all the science that we have. Everything that we've got going for us right now as a species was inspired by nature. So the field of work that I do, sustainability science, is focused on one part of this system. It's called industrial ecology. And it's really thinking not all of the ways we can learn from nature, but what can we learn from nature that will help industry be better, that will help our economy function differently, that will make our phones less harmful and more beneficial. So everybody's familiar with this type of image? You've seen this before. What is it called?
Yeah. Food cycle.
A food web, a food chain, a food cycle. Absolutely. There's something in the middle that a lot of people don't like to think about.
Oh, decomposers that eat everything.
Right, decomposers that eat everything. Now, when I'm talking to my students, when I'm teaching in my classroom, 20, 21-year-olds, I put this image in the middle. Then you know what I put on top of that? A picture of what's in the garbage can, right? One of the big challenges that humans have is that we create all kinds of byproducts. Right? When we're done with an apple core, we throw it into a garbage can. When we're done with a banana peel, we put it in a garbage can, unless you compost, and we'll talk about that later. When you're done with a pen, it's in the garbage can. Can any of these animals or the decomposers in the middle, can they do anything about a pen?
No.
No. Can they do anything about a phone?
No.
Right.
No.
So in nature, we've got this balance, and it's something nature learned how to do over millions and millions and millions of years. Just like we learned how to fly because of birds, industrial ecology says, what can we learn from these exchanges of materials that we could apply to how businesses and companies and economies operate? The premise here is that there's no such thing as waste. If you go to a forest, there is no waste there. Every leaf that falls from the tree, every needle that falls, everything that is a byproduct in a forest is also a food product for one of these other organisms that plays a really important role. So nature says there's no such thing as waste. Can we say that about human systems? No. One of the reasons is because humans don't like to think about that thing in the middle, right? Garbage is gross. You do? Right. Maybe you can do my job in the future too. Because this is, for me, the stuff that's in the middle is the most important thing. If we use resources and throw them into a garbage can, we're not only preventing a food chain from happening, a food web, but we're also creating massive piles of landfill. Has anybody heard, you heard of the periodic table of elements?
Yeah.
Wonderful. All right. And just a quick show, anybody have an iPad or a smartphone or something at home? Every single thing, every single block on the periodic table, except for the radioactive ones, is in a phone.
What?
Every single one.
Or an iPad or like in your TV?
In your TV, yes. All of these electronics.
What about like Alexas? Are they in like Alexas?
Because we have our human systems are very complex. It's very hard to draw a picture of it. But what we can say is the things we make are so complex, and we also make them in a way that they can't be broken down again. So that's what industrial ecology starts to tackle. It says, what can we learn from how nature has evolved over millions of years so that human systems do not have waste? Now, before I go further on that topic, what other things do you think nature does really well? You have the block. Please start.
This is about earlier. I wanted to add this. We have things that we want and we have things that we need, but we need things to make things that we want. And we also need things to make the things that we need to make the things that we want. So it's like an endless cycle of needs and wants.
It can be, definitely. And it starts to feel very overwhelming. Do you want to throw that backwards or back over to someone? Is there anyone who has not had a chance to talk into the cube yet that wants to?
Way over there.
Perfect.
Yeah.
You've been patiently had your hand.
So I thought about like the three-legged stool, and I thought a little bit after, like if you so basically how like the earth is like how everything else is relying on humans. That's kind of like how dangerous it'll be if the water spills. Like you can think of the waters as like humanity, and you can think of like everything else as kind of like how reliable it is.
Yeah.
So if like the cup spills, and like let's say something really bad happens and humans can no longer help, and like how like the amount of time like takes for like life on Earth to go down, that'll be based on how much they relied on humans.
I think that's an excellent insight, and it leads to lots more questions. But that is the reason, right? We don't want to spill that water. Whatever it is that's important, we don't want it to spill. That could be humans, human health, well-being, right? What makes us happy, but we don't want it to spill. I think that's a very good point, a good way to think about it.
Pass it to you.
So what does nature do really well, besides having no such thing as waste?
I was actually thinking back to the stool. Can there be 4 legs instead of 3?
There could be. What do you think would the fourth one be?
I don't know, but like, can there be?
So there's a lot of the work that happens. Some people say there should be another leg for technology. Some people say there should be a leg for policy, right? Governance and laws. We can add as many legs as we want. Sure.
You won't spill if there's no legs.
Well, what we want to remember though is the most important thing is keeping the top of the stool balanced. So if we add more legs, we have more things that we need to keep in balance, more things we need to measure. So we can absolutely add legs. And there are 5 pillars of sustainability is another way of thinking about it. And that would be society, economy and environment, and technology and policy. So great question. And there's definitely a lot more that we could think about. Throw it on over.
It goes back to the stool, but is it possible the water could spill by its own self?
That, I guess theoretically, yes, but then we'd have to say what would make that happen. Right? A big gust of wind, but that would come from an environment, right? Wind would be part of the environment's leg. It's possible. And so again, this idea of a stool, it's not really a stool. It's a way of thinking about all of the important things that we need to balance. Exactly. It's a way of thinking about it. It's a way of remembering that if we only think about money and technology, then we're going to have a problem because we're not paying attention to the other legs on that stool, whatever they may be. The whole point of thinking about a stool is remembering that the seat needs to be flat and balanced so that the water doesn't spill. All right, I'm going to push forward because we are coming up on time. Well, not really, we still have lots of time, but I want you to think about this food web. There is no such thing as waste in nature. We've drawn lots of different pictures about it. It involves decomposers and maybe some things that we might call gross or things we don't like to think about. But if we take that idea and we think about human systems, right? Has anybody ever been to a factory? Okay. Anybody ever thought about where the stuff that we have comes from? That type of thinking, that type of question asking is important because the human industrial food web looks like this, right? We have a box in the middle that includes all the things that we mine out of the ground, all of the manufacturing and factories that are all over the planet, all of the products that are made and in operation, including this building and the seats you're in and all of the technology. And it also includes what do we do when we no longer want those things, right? When these chairs, maybe we don't want them anymore, where are they going to go? Probably going to go to the trash. Right. Could, and this is a really important piece of it, but if you think about human systems, right, these are the main activities that we do, and to do them, we use systems thinking, say, to make these chairs, to make this building, we need raw materials, right? They need to come from somewhere. They might be taken out of the earth, aggregate, concrete, sand. It might be biomaterials, taking trees from the forest or bamboo. It might be metals that we mine from the earth. There might be something like plastic that we synthesize from fossil fuel sources and other chemicals. We need energy to run all the equipment, to turn the lights on, to make it all work. And we get our energy from different sources. Most of them are fossil fuels, right? We have a lot of power and electricity generation. We have a lot of combustion. We have natural gas. When we put all of these inputs into our operating system, we make products. Right? Apple makes phones and iPads. They make lots of other things, obviously, but that's represented by this thing. They make something. A lot of materials go in, they're transformed, and they come out the other side as a product. But we also make co-products, things that are not waste, but they're not the thing the company actually wants to make. And that could be old cardboard for recycling or old metal. The other thing that comes out of these processes tends to be emissions to the air, effluent into the water, and things that we can't recycle, so they go to landfill.
Dr. Russell, can I ask a couple questions that we got from the...
Please, that would be great.
Okay, question and answer. So one of the questions is, how do we get more people to help with our natural environment?
It's a very good question. First thing we have to do is recognize that there is more to the world than just money and jobs, even though that's what we talk about the most, and thinking about it like that three-legged stool. And when other people realize that they won't get the pizza if they don't take care of the environment that all of those things come from, that helps people to care more if people don't already care. But if you are someone like me who already knows that you care about this, then the way you can start to be involved is by acting and speaking and caring and studying and deciding what kind of job you want to do in the future.
Another question is, nature can naturally filter itself, and there's so much we don't know. So are we hurting Earth by trying to understand it, like trying to copy it and stuff? We're technically hurting it instead of leaving it alone.
This is a very good question. Sometimes if we do something without understanding the impacts of it, we can cause more harm. And there's some really good examples of this, right? For a long time, single-use plastics, we did that because we were really thinking that it helped people to be healthier and happier. So single-use plastics, like a straw, for example, means you don't have to put your mouth on a cup. And so maybe you're not sharing germs. They do now. Right. But 30 years ago, we did not have paper straws. Yeah. No, excellent point. But what I will say back to the question is, we don't always have to just try something and hope it works. A lot of science in the past has been, well, let's try this thing and we'll see what happens. And sometimes the thing that happens is a really bad thing. But what we do now, the work that I do, works with models, right? Pictures and math equations that help us understand what could happen without actually doing it. So we can say, what happens if there's an oil spill into the ocean? We don't have to actually pour the oil into the ocean. We can use data and research and models to understand what would happen, and then we know what not to do or why we need to do something differently. What I want you to think about here is the difference between our human industrial system, this food web of how we make all the things we make, and the one that nature has. Right? What's the main difference? Yeah, we have the cube. Who has the cube? Oh, perfect. Do you want to throw it up here?
I think the main difference is the forest and all the scrappings being thrown in the junkyard.
Right, so the materials we're using are different, and where we put them all is different, and there's not necessarily anything to consume it or eat it or change it. All right, one more.
The way we do stuff is pretty different.
Yeah, we do things differently, right? The way we do things we've designed huge systems, factories and electric power systems. We've done that without thinking about nature. We tried to do it with human ideas of what was the most important thing. What that means is we have a model to explain it. We have an economy that takes things out of nature and out of the environment. It turns them into products or energy. And then when we're done with it, we dispose of them. Sometimes we can recycle them, but that's a pretty new thing for a lot of economies. Something that looks a lot more like nature is more circular in shape, right? The big difference here, when we model it, when we draw pictures of these systems, we can see one is kind of like a line. Things go in, we change them, and then they go out and we dump them in a landfill. Maybe we recycle some of them. But in nature, it's just cycled. We have circles. Could be long, squiggly circles. They could be all different shapes. It doesn't have to be a circle. It needs to be circular. I see lots of hands. If you'll bear with me, I'm going to say 2 more things about this. The biggest difference between industrial human systems and that was kind of cool. All right. All right. So what's the difference? Quickly, what's the difference between these 2 things? The shape. The shape is different. Drawing a picture of it, modeling that system is what lets us see how we might do a better job of mimicking nature. So this is a much more complex diagram that talks about how could we make our systems more circular. Has anybody ever, I don't know, sewn a button back on their shirt? Or in your family, in your house? Anybody ever sewed something back together or mended a tear in your jeans? All right. Has anybody ever gone with their parents to get the filters changed on their car? These are activities of maintenance and repair, right? When we do these things, whatever it is we have lasts longer. We don't need to go buy a new one. Has anybody ever, your family ever donated something to Goodwill, or you have an older sibling or a younger sibling and you either get their clothes or they get your old clothes? Anybody have that? I had a lot of that. I had older cousins. I got all their clothes. Those are reuse systems, right? Again, we make things to last for a really, really long time. A sweater is going to live for 50 years if we take care of it, but you're not going to wear it for 50 years. Somebody else can. If we want to get really technical about it, we have systems like refurbishment and remanufacturing. Anybody seen big tractors, farm equipment, bulldozers? The companies that make those pieces of equipment, they're so expensive and they're so heavy duty that they make them to last a really long time. And they also make it so that they can be disassembled, cleaned, improved, repaired, and then put back together again. Have a whole new service life. They could be reused by someone else, or we could make sure that they are as new. They are the same as a brand new version, but they're not brand new. They're using what's already been in existence. Absolutely, yes. Automotive sector, the vehicles, is one of the most advanced systems in the world for being circular. Spare parts, repairs, maintenance, reuse markets, salvage and scrap. At the end of it all, right? If we can't use those parts anymore, if it doesn't work anymore, it can't be repaired, we can recycle it because most of it is metal. We can recycle metals pretty well. So on this side, we take plastics and we take metals and other technical materials, and we have lots of ways of either making them last longer or recycling those materials so we don't have to go back to the environment to get more. For biological materials, and think about food waste, we can cycle these as well. Does anybody have a composter at home? Excellent. So rather than food waste going into a landfill, food waste can be composted and used to take the nutrients back to the soil. But we can also do some other really cool things. We can use bacteria to break down organic waste and create fuel that doesn't have to come from fossil fuels. They're making a lot of clothing out of bamboo and wood, right? Cotton provides a lot of our clothing. We can use biomaterials to create products that we need and want. There is plastic in some clothes. One of the things we can do to fix that is by using more things that are not plastic instead. Right, keep it in use for longer, definitely. All right, I'm gonna pause for a second in case there's any questions. I know there's someone at the back, actually. Do you wanna throw the cube to the back? Do you still have a question? Are you sure? You're welcome.
My question is about all the way back to I forgot what it was called, but I was gonna say plants are like, I forgot about the pizza and the apples. I was gonna say that you can eat plants. It doesn't have to be just like flowers or anything. It could be like watermelon or something. You could keep growing them.
Yes.
And you don't have to like buy it, because you could go to like a relative's house and get some. Then you could save the seeds and plant it to make some.
Definitely. So that takes us thinking though, right? How many people just spit their watermelon seeds into the garbage or on the ground? Or eat them, right? Or we could collect them all and use them to grow more watermelons, right? But that takes us, we all then need to stop and think. What are we doing? Are we putting it into the garbage, or are we finding another way to move it through the system? All right. I'm going to ask everyone to pause for 1 second and stand up and get your wiggles out, if that's a thing that you do. You can jump up and down. You can wave your hands in the air. You can run in the same spot. You can high five the person next to you. It is a long time to sit, and you are doing amazing. I really appreciate it. I have to do wiggling too. My legs are stiff.
That's what I said. They all collapsed.
We just probably wouldn't be able to live, right? That's a tough one. I think personally, the environment, because if that doesn't work, nothing else will work. Yeah, possibly. All right, back in your seats. Excellent wiggles. I needed to do that myself because my legs are stiff. Where is the cube right now? Perfect. Do you want to just throw it to the person behind you? Right behind you, orangish shirt. Yeah.
I'm okay.
Where do we put the recycle? I heard we put is this landfill is a bunch of trash. What do we do with it there?
Yes. Okay. So if you think about it, in nature, there's no such thing as waste because everything in nature is eaten by something else. Right now, we make a lot of things that we can't take apart, and we don't know how to take apart, and we don't have systems or equipment or training to take it apart or reuse it. So recycling is the idea that we can start to design things differently, make them so that they can be taken apart, and then build systems so that we can divert it, collect it, and recycle it to become new feedstock instead. So all of that depends on designing it properly in the first place, though. Because even if we could recycle, technically, a lot of these things are recyclable, but if they're all glued together and we can't separate them, we can't recycle it.
But do we have big machines there to crush them?
There's lots and lots of different equipment. Some of it's really cool. With plastics right now, there's a lot of research going into chemicals that will break plastics down so that we can use them again. It's going to be we have lots of stuff to learn, right? This is where new science is going. New science says, great, we've built an amazing device, but we need to now figure out what to do with it as well. So really quickly, because I have to wrap up, I want to give you an analogy of life cycle thinking and analysis and how you can actually start to think using systems to understand interconnections and help to make better decisions. So life cycle thinking and analysis is really reflecting on all the questions that we could ask about the thing that we want or need. And I'm going to start with an example of cookies. Everybody's eaten cookies before? Excellent. Have you ever participated in making cookies before?
Yes.
Okay, cool. Perfect. But you've seen somebody making them, right? Have you observed how cookies, where do they come from? All right. Well, what we're going to do is dig into that because that's part of the job of sustainability scientists. We look at all of the activities that are involved with whatever the thing is. It could be really complex, like a phone or an iPad or a car or an airplane, or it could be something that's a bit simpler, like cookies. All right, so I just need you to stay focused just a bit longer. Life cycle thinking tells us that we need to explore all the stuff we have by imagining and thinking about where it came from. And we can match that up to this idea of different activities. So we say, where did those cookies come from? Well, if we just think about what happens at your house, I bake cookies, right? Where do cookies come from in my house? The first step, we call it fabrication. I need to get all of the ingredients for those cookies assembled. So we need flour, we need chocolate chips, we need sugar, eggs. Yeah, whatever kind of, they don't have to be chocolate chips, whatever ingredients you want, right? Almost like a recipe. Get all the things that we need. We're also then going to mix them together. And different recipes require you to mix it in different ways. In this example, the only thing you need to mix cookies is a bowl and a spoon and the ingredients. If we were making a car, you'd need a massive factory. You need hundreds of skilled people and advanced equipment. But that's all right, because what we're doing is thinking about where does it come from. We know what goes into it. We know some of the activities that we need to do. Once we have that batter mixed, we put it onto a tray. We put that tray into the oven for a certain amount of time. If we're talking about a vehicle, right, now this might be, how do we bring all the parts together and make the electronics work, test that it's going to work? How do you assemble it?
Yeah.
Exactly. Exactly. So the exact details, whether we're talking about cookies or cars, we can reflect this in the idea of life cycle. We do these activities, we put it in the oven, we get cookies coming out of it, but that's not the end, right? We also might put them in a cookie jar, which means just like inventory, if you've ever seen a big parking lot filled with cars that were just manufactured, that's the same as a cookie jar, only it's filled with cars instead of cookies. Just like the cookie jar, we need glass and a metal lid. Somebody had to make that. The car parking lot needs land, concrete, cement, fences for security. So the same things that we think about for making cookies, we can think about for anything that has been made on the planet. And we can also measure it. We can measure how much ingredients, how much time in the oven, how much electricity to run the oven for that long. We can go even further, and this is a lot of the work that I do as well. To get these ingredients, they had to come from somewhere, right? This is a picture of chickens. Somebody had to raise the chickens. Somebody had to build the barn in which they live. Somebody had to grow the food that they eat and manage the waste that they created. Which came first? Which came first? Yeah, exactly. Too far for me. You need philosophy for that. Chicken. We also need to think about sugar, right? Sugar is an important part of cookies. Where does it come from? Did we grow a lot of sugar in the US? We grow a lot of sugar in the US, but a lot of other countries grow sugar too. So now we have to think about global trade. How do we get sugar that's grown in India to the United States? Right, that's a lot of metal and a lot of fuel. So we can think about how does this come together? What do we need to make it work? If we've got milk in these cookies, we got to think about the cows. If we have flour, we've got to think about all the land to grow the wheat. We go all the way back to the beginning. What did we need to get these ingredients? What tools did we need to assemble them? What activities did we need to do to bake and turn them into cookies? And then what did we need to store those cookies? Anybody ever bring cookies with them to school for lunch? That's okay. I grew up a long time ago. My mom would send me with some cookies in a plastic bag. So it was a long time ago. I don't know if that happens now, but somebody has to make that bag. However you take your cookies, it could be a paper bag, it could be wax paper, whatever it is, somebody needs to make that. It needs to come from somewhere. We also have to think about this question of, you get an apple or cookies? That is a health implication. It ties back to the really good comment that someone said earlier.
Cookie.
Yeah. But then we have to think about the pizza and the apple tree. right? Apples and pizza. I shared this because what we eat is also an important part of the health piece of that three-legged stool. If the only thing we ever ate was cookies, if the only thing we ever make is cars, we aren't going to be balanced and healthy. Bigger picture. Right. Even after we've got the cookies and we've made our good healthy choices, we still have some things that come out that are not, these are the byproducts of making cookies. This is eggshells. What can we do with eggshells? They could go in the trash. Where else could they go? Compost. Yeah, they could go, you could put them in the composter. You could put them in your garden. I put mine in my fish tank because I have snails and the eggshells are really good for snails. But the point is, if you don't think about what this waste product is, you can't come up with good solutions that are not landfill. You need to think about those possibilities and ask those questions. And at the end of it all, often we're gonna have waste regardless. What could we do instead of throwing it into that garbage? So, life cycle thinking really gives us a way of organizing how we think about all of the things around us so that we can ask the questions, of what is needed, where did they come from, what did we have to do, and what happens when we're done with it, right? So we have a life cycle system, whether it's cookies, whether it's a car, whether it's a spaceship, these same principles apply. We have to ask, where did it come from and what did it take to make it? What are we going to do with it when we're done with it? Potentially. Right. So this is a model, right? This is that question. We don't have to go and experiment in the planet and cause harm accidentally. We can model what we already know to understand if our decisions will have a good outcome or a bad one, and that will help us to make better decisions. We map and we model, and then we measure. If it's going to take more electricity and cause more harm than it's worth, maybe we shouldn't do that. That's okay too. But we can't answer that question if we don't model it and measure it. So some of the things that we measure in life cycle analysis is all the things that go into each step. So material extraction, that could be mining, that could be farming, that could be forestry, whatever it is, wherever the material is coming from, what had to go into that to make it, and what were the outputs or the byproducts or the wastes. We get all those things together, we make it, we produce it or manufacture it. We need electricity to manufacture. We need equipment to manufacture. We need people who are skilled and know how to do those things. It means we need some money as well. What are all of the inputs to making things? And then what are the outputs? The pollution maybe, the waste, the recyclables. When it's all done, we're going to package it and ship it out over the world. To do that, we need packaging, we need transportation, we need trucks, we need ships, all that stuff. We need fuel, all the inputs to that activity and the outputs that might go with it. And when people use things, that also has an impact. There's a big difference between a cookie and a phone. What's the difference between a cookie and a phone? A cookie you can eat and a phone you can't? Absolutely. What's another difference? I think, yeah, you want to turn the cube to the, yes, blue sweater? Thank you.
For a phone, you can use it and like download apps, and it's just technology. But a cookie is like, it's made from natural materials that you can buy or you can grow.
Yep, very good points. We'll have one more guess, and then I'm going to wrap all of it up. You're all on the right track.
The difference between a cookie and a phone you can like connect to other people and they call and talk to them.
Yeah, a phone lets us do a heck of a lot more than a cookie for sure.
And then a cookie, you could just bake it and eat it.
So
a phone takes longer to make than a cookie.
I really like that added point. All right. So there's really millions of differences between a phone and a cookie, but the two things I want you to remember, right? The first one is a cookie you eat and it gives you energy. A phone, to work, to watch things, use your apps, or phone someone, it needs to take energy.
Excuse me, I noticed something that makes cookies and phones similar.
Okay.
So you can do things with a phone and a cookie. With like a cookie, you can make different things out of a cookie, and you can do different things with your phone.
Yeah. It's actually, this is a good philosophy question. There are so many things that are different. I'm talking about a phone and a cookie right now because those are the examples that I've been using. But the main differences are a cookie is going to use largely biological ingredients, things that we grow in nature and use, and when we eat it, it gives us energy. A phone is going to take non-renewable resources, plastics and metals, and it needs to be plugged in to have power so that we can use it. Those dynamics are very different, and that means when we use it or we consume it, there's different inputs and different outputs. The product that we're looking at has a huge difference. And the final thing we think about is what happens when we're done with it.
We don't.
So I'm going to show you super fast some pictures because this is how we can organize our thinking. You do systems thinking to understand sustainability. We take raw materials out of the environment. All kinds, all different shapes. That includes energy, whether it's renewable energy or fossil fuels. We process that. Mining activities, sawmills. We have foundries where we convert raw ore into metal that we can use. We also have a variety of ways that we do that. Fabrication is where we turn those materials into products. All different things. We assemble them, sometimes by hand, skilled workers who know how to use power tools and do that assembly. We can do it in factories, right? You can do it anywhere. It's this act of bringing all the parts together. Even if we're talking about ice cream cones. Like this is a lot of equipment to make ice cream cones that we often don't think about. Once we've made those things, we have to package it or finish it. That means putting labels on it, maybe filling that bottle, wrapping it in foil. In this case, this is a picture of Amazon, right? Before anybody ever get a box from Amazon at their door, right? Or whoever it is that it's shipping it, those products need to be put into a package so they can be sent to you. And we need big infrastructure to organize and manage and move it. Inventory, as I mentioned, this is a parking lot of finished cars, just like a cookie jar, only now we're talking about cars. This is a storage inventory space for tires. We need huge technology and systems to store all the stuff that we have made. We utilize really complex transit systems to get these things around the world. Trains, trucks, shipping. We also have some pretty intense warehousing, how we distribute these things. We have a lot of people who do research to understand what's the best and most efficient way to move those. Finally, these things come to us, but if we're talking about a car, we need to put fuel in it to run it. If we're talking about a phone or a laptop or television, we need to plug it in for it to work. Those things need energy to operate, unlike a cookie. They also create some damage just by being in use. We have pollutants, we have wastes, things to think about. Some of the things we use have really toxic materials in them, right? These things may be added so they can do their job, but we should be very careful not to consume them or touch them. But those are some implications once the products are in our houses. 2 seconds. Now, where circular economy ideas can come in and be helpful, right? When we no longer want it or it doesn't work, we could repair it. We could sew, we can add materials, we can fix our shoes, we could take it to a car shop, we can do things to repair. We could reuse things and get really creative with it, right? Reuse can happen at a store like Goodwill or YMCA, or we could do it in our own homes, find different uses. We could refurbish things. right? Old furniture that gets repainted or refurbished. This is a picture of a chair that maybe had some old fabric that nobody really wanted to deal with, but the structure was good. So you take the fabric off and add a new covering to it. But refurbishment and remanufacturing is also a really important activity, even for the US military. You think about big, heavy, expensive equipment. We don't want to remake a new one every time something happens to it, every time there's damage or it gets old. So we can remanufacture and refurbish things at very intense levels. And even Apple has a designated refurbished Apple product line where they take their smartphones back and they fix them up to avoid throwing it away. Remanufacturing, this is a picture of some of the US military operations overseas, right? If you think about some of the big military equipment and vehicles that are all over the world, do you think they want to ship it all the way back to the United States every time it needs to have a brake repair done? Right, so remanufacturing means these are engines for giant equipment that are overseas, and they have people on site who know exactly how to take these apart, fix them up, clean them, get them working again. This is a jet turbine. If you've ever flown on a plane, the odds are it's working with a remanufactured turbine because these are so valuable. We don't want to throw them out just because we want to upgrade it. Recycling is the last thing that we want to do. If we can't do anything else with it, we want to get the material back into the system. So this is a picture of paper, right? It looks really messy, but it's actually all just paper. And if we break that down to fiber, we can turn it into new paper, toilet paper, newsprint, cardboard boxes. We have scrap steel up at the top, right? Scrap yards collect steel. Very efficient process. Has anybody ever put their recycling into a blue bin or some sort of bin? It goes to a facility that looks like this. All those materials run on a giant conveyor belt that runs through a system and it gets sorted by mechanical systems, lasers and optical sorting, technologies, and humans. And eventually it turns into these big giant bales. This is just milk jugs, milk cartons, and other white plastics. This is just paper. Once we sort it, it becomes a lot easier to use it again. All the plastic that we try to recycle, it's eventually going to get shredded and it's going to look something like that. And then, if we can't do any of those things, can't take it apart, this is often what happens, right? The important reason that I'm showing you this is the very last thing is because all those other things I just showed you are interventions that we can make by choosing to do things differently, by understanding how the system works. I know, we're working on it, right? Possibly. There's a lot of infrastructure around the world dedicated to just handling the stuff that we throw into a garbage. What if we... Well, sometimes we do.
Going into space.
Yeah. Right, but arguably we could just do something better with it, right? It's not actually garbage. All right, so I'm going to wrap this up. You guys are fantastic. I love your ideas and I feel super confident about the future. And I know you have a question. Just let me finish this point and then you got a question coming. Okay, the 5 main ideas. If you take nothing else away from this, first, we are part of nature. We are in nature. We need nature. We are impacted by nature. That is why we have to care about that environmental stool. That is why we have to care about planetary boundaries, because all the things that we want to need, if we don't take care of that, they won't work. So we also have to think about this balancing piece. Humans and society, environment and economy, keep that in balance. Whether it's balance on the top of a stool with a glass of water that we're taking good care of, or if it's because we're in that sweet spot where the icing and the sprinkles are on the donut. When we don't know what to do, looking to nature is a really great way to start thinking about solutions. And humans have been doing that for thousands of years, and it's one of the reasons why we've made so many really cool advancements. The things we do can cause harm, but they can also cause good benefits. So we could decide to launch our garbage into space, right? That might cause harm, Or we could decide to sort it and recycle it, or to donate those things that don't actually need to be in the garbage for reuse, or to do something else. And our choice, what we do with it, is the thing that actually makes the difference, whether it has a harmful impact or a beneficial impact. And the way we know how all of this works is by measuring it and studying those systems so that we can make those better decisions. All right, so that's the end of my beautiful PowerPoint slides, but I'd love to, if we have time for questions still, or is wrapping up? Questions? Yes, perfect. All right, where's the cube? Oh, okay, sorry.
And also, after your parents come and grab you, you can also come up here and ask our lovely speaker a question. Afterwards, we'll take this one question and then we're gonna start.
Perfect. Yes, please go ahead.
If we sent our trash into space, what would it harm? Aliens?
Well, we already know that trash is starting to impact satellites, and it's impacting other space studies. So it's hitting like the International Space Station and it's causing damage. Once it's in space, we can't control it. It's already harming human things up there, like our satellites, but we don't know where it's going to go. So we have to say, is it worth the risk?
But
we can't quite do that yet.
But
don't want to make it someone else's problem.
Everybody sit down, please.
But couldn't they just use the trash to upgrade the International Space Station and make it bigger?
We probably need more technology on the space station to do that. But maybe that's the solution. I don't know. It's not my expertise.
Okay, if you have